Everyone, welcome to PRS chemistry classes. In the last sessions we have completed the first colligative property, that is relative lowering in vapor pressure. Now we will discuss about second colligative property, elevation in boiling point. Second one, elevation of or elevation in boiling point. This is the second colligative property, delta Tb. This is the second colligative property. Now let us discuss what is meant by this elevation in boiling point. First of all, can you define this boiling point? Boiling point का definition आपको पता है. The boiling point of a substance is defined as the temperature at which, boiling point का definition देखिए, the temperature at which vapor pressure of a substance or vapor pressure of a solution when it becomes equals to atmospheric pressure. Vapor pressure and atmospheric pressure same होना चाहिए. The temperature at which vapor pressure of solutions becomes equals to atmospheric pressure is known as boiling point of solution. तो यहाँ पर ये boiling point का definition है. In the previous session में vapor pressure के बारे में study किए थे. Completed. Vapor pressure we have completed. So therefore boiling point, elevation क्या है यहाँ पर? What is meant by elevation? Elevation. How the boiling point increases. So आपको पता है यहाँ पर एक graphical representation से study करनी है मेरे को. We'll explain by using this graphical representation. तो यहाँ पर vapor pressure versus temperature. Temperature का axis है ये. Temperature versus vapor pressure. We have considered temperature versus vapor pressure. Now let us consider 2 points. ये vapor pressure 2 points consider किया हमारे पास. Let us consider the point A and point B. Now you can predict from the previous knowledge A and B में हमारे पास 2 components है. We have 2 components, one is solvent and other one is solution. Can you predict which one is solvent and which one is solute among these 2 points? Yes, of course A represents solvent because vapor pressure is more. जिसका vapor pressure ज़्यादा है वो solvent है, जिसका vapor pressure कम है वो solution है. So therefore A is the vapor pressure of solvent and B represent vapor pressure of solution. Now as the temperature increases, and one more point here, this is, let us consider atmospheric pressure. यहाँ पर atmospheric pressure, this represents atmospheric pressure. तो ये atmospheric pressure से भी कम है. As the temperature increases, the vapor pressure of the substance go on increases. At a particular temperature, the vapor pressure of the substance becomes equals to atmospheric pressure. ये जो temperature है, the temperature at which the vapor pressure becomes equals to atmospheric pressure is known as boiling point. ये solvent है, so this is the boiling temperature of solvent T0B. Similarly, solution क्या होता है? To this solvent. Now, so ये solvent है. To a solvent, a non-volatile solute is added. When a non-volatile solute is added, the vapor pressure of pure solvent decreases. Because solvent का vapor pressure ज़्यादा है. When a non-volatile solute is added, it becomes solution. So vapor pressure of solutions is less than vapor pressure of solvent. Vapor pressure decreases, and this vapor pressure increases with temperature. So the vapor pressure increases at a particular temperature. This reaches to an atmospheric pressure. This temperature is known as Tb, that is boiling temperature of solution. A solvent का है and this is for solution. S solution. The difference between this temperature, boiling temperature का जो difference है, delta Tb. This we can call delta Tb, and this is given by Tb minus T0B. This is delta Tb. तो ये क्या हुआ यहाँ पर? सॉल्वेंट को a non-volatile solute ऐड करने के बाद boiling temperature of solution ज़्यादा हुआ है. Solution का boiling temperature ज़्यादा है. The increase in the boiling temperature is known as elevation in boiling point. Simple concept है, definition. Define elevation of boiling point. क्या है यहाँ पर? The difference between boiling temperature of solution and solvent is known as elevation in boiling point. A difference, or you can say increase in the boiling temperature of solution upon addition of non-volatile solute is known as elevation in boiling point. ये इसका कांसेप्ट है. ठीक है, स्क्रीनशॉट और एक्सप्लेनेशन के लिए ग्राफ आपको यूजफुल होगा. नेक्स्ट, डिफरेंट एक्सपेरिमेंट शोज दैट. देखिए यहाँ पर सॉल्यूशन है, सॉल्यूशन का बॉइलिंग पॉइंट, एग्जांपल वाटर, प्योर वाटर, बॉइलिंग पॉइंट कितना है? बॉइलिंग पॉइंट ऑफ वाटर इज 100 डिग्री, 373 केल्विन. वो 3 से वाटर को if we are adding 1 mole of x, 1 mole of y, 1 mole of z, any different substance you are going to add, 1 mole of substance, so number of moles के ऊपर डिपेंड है. when 1 mole of x, y, z, when it is added, the boiling point difference becomes same, it becomes equals to same for all these x, y and z. So therefore this indicates, different experiments indicates experiments which shows that experimentally we know that ये जो terms है delta TB, this term is directly proportional to molar concentration of solute in a solution. तो ये delta TB, elevation boiling point, is depends only on molar concentration of solute particle. Therefore this is a colligative property है. Now हमको क्या है? molar mass determine करना है. यहाँ पर we need to determine molar mass of solute from elevation in boiling point. उससे पहले तो ये proportionality symbol है. So delta TB is equals to KB into M. So this KB is a constant known as proportionality constant, and this KB is known as molar elevation constant. KB is known as molar elevation constant, or we can call ebullioscopic constant. Ebullioscopic constant बोल सकते हैं इसको, ebullioscopic constant. The unit for this, unit important है, kb is equals to Kelvin kg per mole. Its unit is Kelvin kg per mole. Sometimes degree Celsius kg per mole भी दे सकते हैं, प्रॉब्लम है. Kelvin kg per mole is the SI unit. Now इसका definition क्या है? What is the definition of ebullioscopic constant? Kb can be defined as, so for if ये equation में m is equal to 1, that means ये m is equal to 1 हुआ तो क्या हुआ? m is equals to 1, that means kb is equals to delta tb. So for 1 molar solution, how to define? m is equal to 1, that is for 1 molar solution. ये जो difference है, difference को हम kb बोल रहे हैं. For 1 molar solution, ebullioscopic constant is defined as difference between the boiling temperature of solution and solvent. ये इसका definition है, ऐसा यूनिट definition. ऑब्जेक्टिव के लिए ये kb फाइंड आउट करने के लिए आपको एक फार्मूला है. kb can be calculated by the equation kb is equals to mtr mt square, m boiling temperature of solution, ये molar mass of solvent, r divided by enthalpy of vaporization into 1000. Enthalpy of vaporization into 1000. In this place enthalpy of delta H, enthalpy of vaporization की जगह delta H की जगह enthalpy of vaporization is equals to molar mass of solute into latent heat of vaporization भी हम लिख सकते हैं. तो ये फार्मूला से भी क्या, if latent heat of vaporization is given, in that case kb is equals to, it can be calculated from RTB square, m के जगह जैसे TB square R divided by, इसके जगह ये वैल्यू से m गेट कैंसिल हो जाएगा, तो latent heat of vaporization into 1000. ये फार्मूला भी आप यूज कर सकते हैं. kb is equal to this is one part, this is ये related to the ebullioscopic constant का related concept है. Now continue this. So how to determine the molar mass? मोलर मास डिटरमाइन करना, क्योंकि आपको फार्मूला चाहिए, तो इसके लिए मोलैलिटी के जगह in place of m you just substitute its values according to definition. Delta TB is equals to kb into m के जगह m is nothing but what? मोलैलिटी. definition क्या है? मोलैलिटी is nothing but number of moles of solute divided by weight of solvent into 1000 m की जगह उसका डेफिनेशन सब्स्टिट्यूट किया। So where m is equals to molarity, molarity का definition होगा n is nothing but number of moles of solute. इसका एक फॉर्मूला है number of moles nothing but given mass by molar mass. Let us substitute the same thing. So Kb is equals to Kb into Wb divided by Mb, given mass of solute by molar mass of solute, Mb की जगह into 1000 है, into 1000 divided by Wba divided by Wk. This is the formula. ये डेल्टा टीबी का, बट वी रिक्वायर्ड एमबी का फॉर्मूला चाहिए, देयरफॉर एमबी इज इक्वल्स टू, दिस इज द फाइनल एक्सप्रेशन, एमबी इज इक्वल्स टू क्या है, एमबी इज इक्वल्स टू, रीअरेंज करो इक्वेशन को, केबी इंटू डब्ल्यूबी इंटू 1000 डिवाइडेड बाय डेल्टा टीबी इंटू डब्ल्यूए. This is the equation to find out molar mass, to determine the molar mass of solute from elevation of boiling point, where Kb is abelioscopic constant, its value is given. If it is not given, you can calculate by using this expression. Wb, weight of solute into 1000, delta Tb, elevation of boiling point, either directly or indirectly this values will be given, or else you need to calculate. Wa is nothing but weight of solvent. This is the second colligative property. देखिए बहुत सिंपल है, यहाँ पर भी like relative lowering vapor pressure, वहाँ पर भी डेरिवेशन तो नहीं पूछते आपको, but this equation is required. Relative lowering vapor pressure का जो फॉर्मूला है वो फर्स्ट इक्वेशन, उसको इक्वेशन नंबर 1, दिस इज इक्वेशन नंबर 2, सेकंड इक्वेशन, और दो इक्वेशन मिलेगा आपको डिप्रेशन इन फ्रीजिंग पॉइंट एंड ऑस्मोटिक प्रेशर में, to calculate the molar mass. So this is the second colligative property. Note this, take a screenshot or note the concept. So now just recall what is meant by elevation of boiling point. Boiling point is nothing but the temperature at which vapor pressure becomes equals to atmospheric pressure. Boiling point बोल रहे उसको. Solvent का boiling point particular value से, वो solvent को if you are adding a non-volatile solute, तो वेपर प्रेशर कम हुआ, वेपर प्रेशर कम हुआ तो बॉइलिंग पॉइंट ज्यादा हो जाएगा, बॉइलिंग पॉइंट इज मोर. तो यहाँ पर डेल्टा टीबी, वेयर इज डेल्टा टीबी इज नथिंग बट, डेल्टा टीबी क्या है यहाँ पर, डेल्टा टीबी इज नथिंग बट टीबी माइनस टी नॉट बी, टीबी माइनस टी नॉट बी. रिमेंबर ये जो कॉलिगेटिव प्रॉपर्टी है, ऑल द कॉलिगेटिव प्रॉपर्टीज आर इनवर्सली प्रोपोर्शनल टू मोलर मास. Molar mass and colligative properties are inversely proportional. In this case, ये जो boiling temperature of solution है, this boiling temperature of solution is directly proportional to this colligative property, because delta Tb, ये Tb is equal to क्या हो जाएगा, delta Tb plus T naught B. So therefore इसका वैल्यू से इंक्रीज हुआ तो डेल्टा Tb का वैल्यू भी इंक्रीज हो जाएगा, therefore these two are directly proportional. So in this case Mb is inversely proportional to colligative property and Mb is inversely proportional to boiling temperature also. Molar mass increase हुआ तो boiling temperature क्या हो जाएगा, decreases, क्योंकि decrease colligative property and molar mass inversely proportional है. So this is about the second colligative property. इसके बाद में इसके ऊपर आपको problem solve करना पड़ेगा. Problems you need to solve on this. So this is about the second colligative property.